Good morning, students. In the last class in chemistry, we discussed about chemical reactions, characteristics of chemical reactions, systemic representation of chemical reactions, word equation, formula equation, conversion of skeletal or unbalanced equation to balanced chemical equations. Also, we discussed ways to make chemical equations more informative along with its limitations. Today we'll study chemical reactions on the basis of number of reactants and products, type of reactants and products, nature of the products. There are 5 main chemical reactions. These are combination reactions, also known as synthesis or addition reactions, decomposition reactions, which are reverse of combination reaction, displacement reactions, also known as substitution or replacement reactions, double displacement reactions, also known as double replacement or substitution reactions, and finally, oxidation reduction reactions, also known as redox reactions. In this lesson, we will see combination, decomposition, and displacement reactions. This is the representation of 4 basic chemical reactions. The first one, 2 substances combine to form a new product. Second type of reaction involves one substance being broken down to form 2 new things. Third one involves the replacement of the part of the compound by highly reactive entity, and so is the formation of new substances. Fourth one is the double replacement of the entities between their components and resulting in formation of 2 new substances. Combination reactions, a reaction in which 2 or more substances, which can either be elements or compounds, combine together to form a new substance, is called a combination reaction. Many combustion reactions are the examples of combination reactions. We can see A, B, C. The 3 entities of the reactants combine to form ABC after the change as a single product. 2 or more elements combine to form a compound. 2 or more compounds can combine to form a new compound. Or an element and a compound can combine to form a new compound, a single product during combination reaction. These are a few examples which show combination reaction. First one, magnesium and oxygen combine when heated to form magnesium oxide. Word equation involves magnesium plus oxygen gives, as in the form of arrow, magnesium oxide. Formula equation involves the formula of various entities. Mg plus O2 gives MgO. Since oxygen atoms are not equal in the reactant product side and it is less in the product side, we have to balance this formula equation, which is an example of skeletal equation or unbalanced equation. To balance the equation, we either can multiply and write the coefficient or can use the variable. Here we have multiplied the number and added the coefficient. Since oxygen atoms are less in the product side, so we have multiplied 2 here in the product side to balance oxygen atom. 2 mentioned here as coefficient. This multiplication result in equal number of oxygen atoms to both the sides. When we consider now magnesium atoms, after multiplication and addition of coefficient, it's more in the product side, that is 2. So to balance to the reactant side, we again have to multiply 2, and so we write coefficient here. Thus, the balanced equation now can be called as 2 molecules of magnesium combines with 1 molecule of oxygen to form 2 molecules of magnesium oxide. Solid state of magnesium undergoes the change, hence we do specify S. Oxygen is the gas, so we do specify it as G, and the product is magnesium oxide, a white ash, so we can mention it as S to make the formula equation, which is also balanced, more informative. Second example, calcium oxide, which is also known as lime or quicklime, reacts vigorously with water to form calcium hydroxide or slaked lime. Word equation will be calcium oxide plus water gives, as an arrow, calcium hydroxide. Formula equation will be using the formula of each and every entity. CaO plus H2O gives, showing my arrow, Ca within bracket OH whole 2. Since each and every element is having equal number of atoms to reactant product side, as calcium atom only 1, oxygen atoms are 2, hydrogen atoms also 2, this formula equation is also balanced equation. Second type of chemical reaction is decomposition reactions. Decomposition reaction is a reaction where a more complex molecule breaks down to form 2 or more simpler products. Usually, a big molecule, which is compound, breaks down to form 2 or more simpler, smaller molecules, which either can be the compounds or can even be the elements. Breaking down a big molecule to form smaller molecules require external factors. A decomposition reaction is a chemical change in which a single compound breaks down into 2 or more simpler products. So we do have only one reactant and 2 or more products. The products can be any combination of elements and compounds. Most decomposition reactions require energy in the form of heat, light, or electricity. A few examples of decomposition reactions. When electricity is passed through molten sodium chloride, it decomposes to give sodium metal and chlorine gas. Word equation is sodium chloride in molten state by passing electricity breaks down to give sodium metal and chlorine gas. Formula equation will be NaCl by passing electricity gives, represented by an arrow, Na sodium metal plus Cl2, the formula of chlorine gas. The formula equation is having unequal number of chlorine atoms to both the sides. Since this is an example of skeletal equation, we also can write the balanced equation too. Second example. When silver chloride is exposed to light, it decomposes to form silver metal and chlorine gas. What equation will be? Silver chloride, white, in presence of light gives silver and chlorine gas. Formula equation will be AgCl in presence of light. The condition of the reaction, white powder turns grayish white as silver Ag and along with the release of chlorine gas Cl2. Third example, when potassium chlorate is heated in presence of catalyst, it decomposes to potassium chloride and oxygen gas. Word equation is potassium chlorate in presence of catalyst as well as on heating gives potassium chloride plus oxygen. KClO3 is the formula of potassium chlorate. Presence of heat and catalyst gives KCl, potassium chloride plus O2. The three examples show different factors for decomposition reaction. The example 1 shows the passing of electricity or electric current. Second example gives us the exposure to light, and third, the heating. Hence, decomposition reactions are of three types based on the factors or external factors required. The first one is electrolysis. Reactions in which compounds decompose into simpler compounds because of passing of electricity are known as electrolytic decomposition. This is also known as electrolysis. Example, when electricity is passed in water, it decomposes into hydrogen and oxygen. If we observe this diagram shows the experimental way of electrolysis of water, where in a beaker we do store water, we do fill the beaker with water and add dilute hydrochloric acid. We place two carbon rods attached to the two terminal of the battery. The terminal of the battery, if positive, and the electrode attached to it acts as anode, and the carbon rod which is attached to the negative terminal of the battery acts as cathode. When switch is on and electric current passes, water decomposes to hydrogen and oxygen gas. During photolysis or photolytic decomposition, the big molecule gets decomposed into two or more resultant products when light is supplied to reactant. Light energy acts as the factor to break down the molecule. Photographic film contains photosensitive coating made up of silver bromide. Photosensitive substances are substances that undergo chemical change when exposed to light. The decomposition reaction, which is carried out by heating the reactant and it's breaking into two or more simpler substances as products, is known as thermolytic decomposition or thermolysis. The diagram shows the action of heat on mercuric oxide. The grayish color of mercuric oxide turns white on heating as it changes to mercury along with the release of oxygen gas. When we bring a matchstick burning close to the mouth of the test tube, we observe that the spindle rekindles. Since combination is the addition reaction and decomposition reaction is the reverse of combination reaction, there are some differences between them. In combination reactions, one or more reactants combine to form a single product, whereas in decomposition reactions, a single reactant is decomposed, broken down to form one or more products. Second, energy is usually released during combination reactions, whereas energy as in the form of heat, light, electricity, etc. is absorbed during decomposition reactions. Elements or compounds may be the reactants in combination reactions, whereas a single compound is the reactant for each and every decomposition reactions. So with this, we will have completed the two types of reactions. The third reaction is displacement reaction, a reaction in which a more reactive element displaces a less reactive element from its compound is displacement reaction. Both metals and non-metals take part in displacement reaction. Like for example, reaction of iron nails with copper sulfate solution. This can be represented with this diagram. We can see in a test tube, a solution of copper sulfate has been taken. An iron nail has been placed in it. We then leave the setting undisturbed for few hours and observe it after a few hours. We observe the color change of the solution. We see the solution now turns light green. In this reaction, iron displaces copper from copper sulfate solution. The deep blue color of copper sulfate solution disappears or fades due to the formation of light green solution of iron sulfate. A red-brown coating of copper is formed on the surface of iron metal or nail. This displacement reaction is possible because iron is more reactive than copper. Each and every reactive element is capable enough to displace less reactive element from its compound. To identify the reactivity of the elements, we do have a series of elements, a vertical arrangement of elements where the top elements are highly reactive, the middle elements of the series are moderately reactive, and the bottommost elements are less or least reactive. Is reactivity series of elements. A very common example of reactivity series of elements is shown here. So the elements which are most reactive to more reactive can displace the elements which are moderately reactive or less reactive from their particular compounds. This series also shows the presence of carbon and hydrogen, the nonmetals in it, as these two nonmetals show substitution or replacement reactions. A few examples of displacement reactions are when a strip of lead metal is placed in the solution of copper chloride, then lead chloride and copper metal are formed. Copper chloride, which is green solution, because of addition of lead, bluish gray, turns colorless. and the copper obtained is red-brown. The colorless solution is of lead chloride. The formula equation can be represented as CuCl2 plus Pb gives arrow PbCl2 in aqueous solution plus Cu. S represents the solid state of copper. Second example. Magnesium metal reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen gas. What the equation will be? Magnesium plus dilute hydrochloric acid gives the product magnesium chloride along with hydrogen gas. Formula equation: Mg plus HCl gives MgCl2 plus H2. Since chlorine atoms are not balanced, hydrogen atoms are not balanced, we need to balance this skeletal equation or unbalanced equation to justify law of conservation of mass. To balance the equation, we do multiply 2 in the reactant side to HCl and write coefficient 2 here. With this, we can take up the balanced chemical equation as 1 molecule of magnesium combines with 2 molecules of hydrochloric acid to give magnesium chloride, 1 molecule, and a molecule of hydrogen gas. These are the 3 examples of displacement reaction. These also are the first three types of chemical reaction. These reactions gives various types of chemical substances or products of daily use. In our next class, we'll continue with the other 2 types of chemical reactions.